Alright, let's take a look at the second section in Chapter 2, which is continuing on with equations of lines. And we already talked about this one a little bit, but standard form is ax plus by is equal to c. So you just move your x's and y's next to each other. And of course, we identified this in the last section, but a has to be positive. And of course, our old friend, the slope-intercept form, y equals mx plus b, where m is our slope, our rise over our run, rise divided by run, and then of course our b value is our y-intercept. And we said that our y-intercept is always going to have x value of equal to 0, and then our b coordinate, our point, is going to be there. So let's just get right into it. They give us a couple of graphs in the first couple of problems, and they want you to write the first one in slope-intercept, so y equals mx plus b, and they want us to write the second one in standard form, and we know that a has to be a positive integer, and b and c are also integers as well. So let's go ahead and see if we can find the y-intercept to begin with. Looks like that's up the graph 1, 2, 3, 4, 5, 6, 7. So we have 0, 7 for a point, and we have 1, 2, 3, 4, 5, and up 1, 2, 3, 4, 5. So our second point is 5, 5. And, well, how are we going to solve this one? It's really up to you. We certainly could find the slope by using y2 minus y1 divided by x2 minus x1. Or we could simply just count this one since it's identified for us on the graph. So let's just do that. So here we're going to go down what? Go down 2. And then we're going to run to the right 1, 2, 3, 4, 5. So we have a negative 2 over 5 for our slope. Well, since we have the y-intercept and we didn't have to guess on that, it was actually a point identified, we can just build this slope-intercept equation, plugging in our known values of negative 2 over 5 for x, right here. And looking at the graph, we're going to use 0, 7. So 7 is our y-intercept. And that's pretty much it for that problem. Well, the second one, let's use the same process. Let's put it in y equals mx plus b, even though we know we need to fix that because it's not standard form. But this one has a nice crossing spot, right? So this one goes and crosses the y-intercept at 1, 2, 3, looks like 4. So it's down 4, so it's negative 4. And then we have to find the slope. So our b is equal to negative 4. And what is our slope? We're rising up 1, 2, 3. And we're going over 1. So the slope would just equal 3. So y equals negative 4x plus 3. And this is not in standard form, it's slope-intercept, so we just need to move this quantity negative 4x over by adding 4x. And now we have standard form where a is equal to 4 and b is equal to 1 and c is equal to that 3. Okay. Well, let's see what we have on the next page. We'll do a couple of these. Number 3. Now, number 3 is really not that interesting because they gave us the slope and they gave us the y-intercept, so we could just directly put it in slope-intercept form. And well, let's go ahead and do it. So if we move the 1/2 over by adding 1/2, we're not in standard form, are we? because we have this fraction identified over here, this 1/2, right? So how are we going to resolve that? How are we going to take care of that fraction? How are we going to get rid of it? Well, you can always multiply a fraction by its denominator to cancel it out. So when you distribute that 2 to both terms inside of here, you get, for the x, you get 2 over 2x, which of course equals 1. And then we have 2 times y equals 2y, and then 6 times 2 is 12. So now, when we clean that up a little bit, we get that our a value is equal to 1, and our b is equal to 2, and our c is equal to 12. Okay, let's take a look at number 4, because here they don't give us the y-intercept. This is not the b value, is it? Because it doesn't have x equal to 0. So this is just some point on the graph. But they do give us the slope, right? So we have y is equal to mx plus b is where a good starting place. And just remember that that's an x-coordinate and that's a y-coordinate. And notice that we have y equals something here, and we have the slope times x. So we can just substitute our x and our y value into our slope-intercept formula, and then the only thing missing would be b. We can solve for that. So we have one unknown. So what is our y value? It's 2, and our slope is given to us as a 1/3, so we're going to plug in a 1/3, and our x value is 4, and we can solve for b. So we need to isolate b or get it all by itself. So we need to multiply this 4 times 1/3, top to top and bottom to bottom. Get 4/3 equals 2 plus b. And the quantity here is positive 4/3, so I'm going to subtract 4/3. And of course I'm left with b is equal to, let's do the subtraction over here. Of course you could use a calculator if you wanted to double check yourself, but this is easy enough to do without. In order for us to subtract these fractions, they have to have common denominators. So we're going to multiply this 2 by 3 over 3, which is of course just the quantity of 1. So top to top would give us 6 over 3. And notice that now our two fractions both have the same denominator, which is 3, so we can just subtract that. And of course we get that that equals a positive 2/3. So in slope-intercept form, now we have everything we need. And we can do it right here. Y equals m, which was given to us, is 1/3 x, and we just calculated b right here, so we just plug in 2/3. Okay, let's see if there's anything else. I do want to do one of the parallel perpendicular problems. Okay. On number 7, let's talk about a way to do this. Well, first of all, they didn't give us the slope here, did they? But we can use the slope formula where we take and subtract the y quantities, which will give us our rise, and subtract the x quantities, which gives us our run, and then we would have a slope value that we could use just like we did on the previous problem. Alright, let's take a look at number 9. And remember from class we talked about that little mnemonic device, passport, where we said that pass stands for parallel lines have the same slope. And then remember when we wrote passport, we put the T upside down to indicate perpendicular, but perpendicular have reciprocals, are slopes that have opposite reciprocal relationship. One's going to be positive, the other one has to be negative, and then they're going to be reciprocals of each other. So we can use that line of thinking to solve number 9 and 10. So let's just let's take a look at number 9. So they both of these problems require that I know the slope of one line, right? So in this problem number 9, there's a line that's graphed up here. Let's say it's in red. And in order for me to find a parallel line, it has to also have the same slope as that red line. But in this case, they give us a spot on the blue line, 5, -3. So maybe it's down here that the blue line passes through. So notice that the red line was given to us in standard form. So we can use this equation to find the slope of the red line, and then we're going to use it to find the slope of the blue line. So we have to take a look at our red equation, which is 3x minus 4y equal to the quantity of 8. And since we want to know the slope, we're going to put it in slope-intercept form, which is y equals mx plus b. So let's go ahead and solve this red equation. So we're going to get everything isolated so that y is all by itself. Of course, that goes to 0, and we have a negative 4y is equal to negative 3x and a positive 8. And then to solve for y, we just simply have to divide everything by negative 4. And so our red line has a slope of what? Negative divided by negative gives me a positive 3/4 x minus 2. And quite honestly, all we really care about is this slope value of 3/4. Since these two lines are parallel, and the red line had a slope of 3/4, the blue line is also going to have a slope of 3/4. So now let's operate on this blue line, and just recall that we're going to use mx plus b. And remember, we were given an x and a y coordinate, and so what we're going to do is just simply, every time we see y, we're going to plug in negative 3 in this problem, and every time we see x, we're going to plug in 5. And since we know the slope of 3/4, the only thing left to solve for is this b, the y-intercept. So here we go. Y is equal to negative 3. Our slope is 3/4. Our x value is 5. And our b is here. Alright. Let's try something a little different on this one. Let's get rid of our fraction in this problem. There's only one fraction right now, and it has a denominator of 4, so recall that if we just multiply both sides of the equation by 4, we would cancel this denominator of 4 out, and we wouldn't have any fractions. So just remember that you have to distribute everything by 4. So when we do that, when we distribute here, that 4 is going to cancel that 4 out, and all you have is 5 times 3 is 15. But don't forget that this b is a number, so we have to multiply it by 4. Alright, so now that what happened? Oh, looks like I had some work left over. Let me erase all this. Alright, so where were we? Oh yeah, we're solving for b. So now we have negative 12 equals 15 plus 4b, and we're going to subtract 15 on both sides, and negative 12 subtract that would be a negative 27. Of course that goes to 0, and we have 4b. Well, our y-intercept is not a very pretty one, is it? But nonetheless, we can solve it. So we get negative 27 over 4. And now let's go back up to the problem, because I'm not sure what they ask us. Oh, they want it in standard form, right? I suppose I should have just left it alone. I wasn't thinking. It has to be in standard form. So we actually could have No, let's just do it. So we have, we'll do it in green. We have y is equal to 3/4 x minus 27 over 4. That's our b, right? And this time, luckily our denominator is both 4. So if I multiply the right-hand side by 4, we get to kill both of these fractions off. But don't forget that we have to multiply the left side of the equation by 4 as well. So we have 4y is equal to 3x minus 27. And almost finished. We got to subtract 3x over here. And we get negative 27, because of course that equals 0. And we have a negative 3x and a plus 4y. And you think you're finished, but you're not quite, because remember, a has to be a positive quantity and it's negative. So just remember, real quick shortcut is, think about multiplying everything by -1. That's all it does, is reverses the sign of each term. So negative by negative gives me a positive 3x. The positive 4y turns into negative 4y, or subtract 4y, and the negative 27, when multiplied by -1, gives me that positive 27. Okay, I'm going to stop this one now.